Hello. Hi everyone. This is Manikandan Selvam from SuperIndex DB. The SuperIndex DB is a database server and we call the fastest database server on the planet. Like how this is going to be the fastest database server on the planet? If you have a question, right? So this video is going to talk about that. Please, continue this video and you will definitely get the new ideas. Like this video's topic is how SuperIndex is different from others. Um, so before we talk about how SuperIndex is different from others, we'll talk about the basic idea about the database. The database records, is it a relational? Is it connected? All the rows in a table, is it connected? Literally speaking, it will not, right? There won't be any relations between the rows in the table. So usually the database records sit like this, you know, without any connection. But who connects all the data in the world? Say, for example, you have a employee ID and the employee name, and there is a connection between the employee ID and the employee name, right? So everything, it's not only employee ID or employee number. Everything in the world nowadays, like SSN number in United States, it's connected to the person, and the security information, it's connected to the incident, and the Aadhaar number in India, it is connected to all the records. So there is a connection in the database, right? So usually the database records arranged in the proper way, in the sequential way, or sometimes in the binary way, sometimes in the tree data structure. There are a lot of structures of the data. So that's why we call it a data structure. So if you arrange all the data in the table or in the database, we can say it will be like this. Like just see this image. We can imagine that our records are sitting in a relational way, right? Okay. Um, Usually in a database, you could have seen or not, I'm not sure. Like we can insert a record or we can update the record and we can delete any records. Say, or you can search some record. Say, for example, SSN number in United States or Aadhaar number in India. Like if anybody want to add a Aadhaar number, Aadhaar card, it's an insert into the database. Or somebody want to change their address, update their address, it is going to be the update address in the SSN table or the other table. Or if somebody want to fetch particular Aadhaar ID, want to know the details, or somebody want to fetch the SSN details in SSN database, there is a search option is there. Like when we say search option in the database, it's a painful area. You know what? Because it's a big table scan. Say, for example, we have uh, lot of people in India. The lot of records in SSN table or the other table, and say 100 million, right? 100 million records, and you want to search a particular record. So how usually the database search the particular record, the particular SSN or the particular Aadhaar number is, like it goes to the table, the table which is in the database, and it goes to the first row and search the record whether this record is matching. If not, it will go to the second record and it will search again. It will go to the second record. It will validate again. If it not matches, again it keep goes third row, fourth row, fifth row, something like that. So that is a usual sequential operation in the database. Say how that will happen. You can see in the picture based animation. See I mean already we imagined that these are the database records. Low. So first record it is searching, and oh, the first record is not matching with the record which we are expecting, maybe the SSN number or the Aadhaar number in India. So we go to the second record. No, second record also is not matching. So We go to the third record, fourth record, fifth, sixth. It keep continuing, right? So in particular record that is matching with the the search record. So so whatever we have done so far, it's a time, it takes time, response time, as well as it is not only time, it is also it utilizes your system based stuff like the CPU utilization, memory utilization, and a lot of things it will be utilizing in the operating system as well as in the hard disk, right? So it's a big work, the big table scan and the big response time and everything it happens. So this is the usual way, like how we search the record in the database or in the table, right? So what's happening? Like, okay, if you want to quantify, like what is the total number of seconds it is taking, it usually takes different timings. It depends upon the record. It depends upon the number of records in the table. It depends upon the quality of the data type. Say address, sometimes it's very big, and the Aadhaar number, it will be 16-digit number. Credit card number, it will be a 16-digit number. Or if you see uh, employee ID, it will be 5-digit number. So it depends upon the data type as well as the number of records it just contains in the table. So for our example, we can take that it takes 10 seconds, okay, in one particular table combination. Okay, it took 10 seconds to get a result, okay, in one particular operation. Okay, so, is it acceptable? This 10 second is acceptable in the world? No. See, nowadays websites are very fast, right? And we need the fastest database server. We need the fastest database search, and we need fastest web applications. Because see, the world is keep going. You know, the way how the things are happening. We must respect the performance, right? So this is not acceptable. That's why the industry leaders or the industry pioneers, what they have found is already they have a concept called, okay, I mean, why this is happening? This is because of the sequential search. Okay, the industry has found, the solution for that. It's called index. Index is available in all the traditional databases. You go to any database in the industry, you have a index concept. Like index is based out of some different data structure called BT data structure or binary tree data structure. So the data structure, it gives some flexible options. Instead of going to every record in the table and just compare it with the required search rate data, instead of searching or I mean searching and I mean mapping, so we can reduce the number of operations. So that's a basic concept of index. Say like what does this index do? Okay, I'll give you the basic idea. The basic idea is, you imagine the tree. The tree has leaves or the branches, right? The branches will have a sub branches, something like that. Say for example, number one here in this example in this diagram, right? Number one have two branches, 2 and 3, and 2 has 4 and 5, and 3 has 6 and 7. So something like that, the branches are there. Like how index is improving the response time means, say I want to search a employee with a salary of 6,000 rupees, okay, or $6,000. Like instead of going one by one, I can first divide the entire salary level, right, from minimum to maximum into off. Say for example, the minimum salary of that company is 1,000 rupees or dollars. The maximum salary of that company is $100,000 or 100,000 rupees. Like I can divide that into 50%. That is 50,000, right? So uh, so the 50% salary holders, I'll keep it in the left tree, and the 50% salary holders, I'll keep it in the right tree. So that if my search is below 50%, below 50,000 rupees, I don't want to search the records which are more than 50,000, right? So I'll just go to the tree, the branch, which is lesser than 50,000. So that's why the tree, the 50% effort will be reduced. Then again, in the 50%, I'll divide it again 25,000 and 25,000. And again, the 25,000, I'll divide it to 12,500, 12,500, something like that. I keep dividing, and finally I go to the record. Uh, but this is also like a traditional way of search. Only the thing is, we are eliminating a certain percentage of records in the search, right? So obviously, index is giving you the better solution for response times. Like practically, you want to know, or you want to understand how index data structures work. Say index data structures keeps the records in a table and the database like this. Just imagine the records will have a tree-based connections, right? So when we have a key-based connections, say if the same search, whatever the search we have done in the earlier table search without an index, the same thing. Now we are going to do the search, the same record, for example. So what's happening here? So we are going for the search. We are first searching the first record. No, it's not matching. Then again, I'm doing the tree-based divisions and the index. I mean, this is an example of the index, and we have indexing concepts in a different way. We can give a index with the index key, some magic number, which will have the magic number is something like, you have a postal card and you keep it in the postal cover, and the cover is the index key. So that cover is very important, and we keep it somewhere. So whenever we do the search, and I'll go to the cover and I'll find it in which rack this particular postal card is available. So that is another way of indexing. So this is the simplest way of indexing. So the search is happening. Oh, we got it. We got the record. In a number of operations are less, the response time is less, and the CPU utilization is less, and whatever the system level operations on the hard disk and everything is less. So that is what the indexing is helping us, for the response time improvement in the database. Okay, it reduces the time and effort. Say 2 seconds in the same table combination. Um, I mean, I'm the same example, whatever we took earlier. Say it was 10 seconds. Now it's 2 seconds, right? So the indexing is helping 8 seconds, from 10 seconds to 2 seconds. So it's helping us. Are we happy? Happy with index? Industry is saying yes. See, you go to the traditional RDBMS databases. There is a NoSQL databases. Now I'm not going to talk about that. That's another concept, but I don't think that is a good concept. See, NoSQL is not actually processing, whatever the records you want. It's not really processing the table scan and fetching the records to you. The NoSQL is the views, like, the predefined answers. I'm keeping it. See, I know that tomorrow morning somebody will come. His name is Ravi, and his Aadhaar number is this, and he needs this details, other details. So before he comes to the searching station, I keep some view for Ravi. Ravi, when you come, your data is predefined, and such data is available. So this view you can use it. That's a NoSQL concept. Now I'm not going to talk about it. I'll talk it in other videos. But that NoSQL concept also is not solving all the problems. And this indexing, is it solving the issues? No, I don't think this is. We are not happy with this, because the reason is, if the number of records in the table, if it goes to 100,000, say 1 billion, 1 trillion, if the number of records grows, yeah, I know in the industry there are several databases with many tables, which has trillions of records, where you need to do the search. See, other number, I cannot say that I can divide the table, right? Now, north part of the India and south part of the India, different other numbers. So first I'll go to the north part of the database. and I'll search the Aadhaar number. If it is not there, then I'll go to the south part of the database and I'll search the Aadhaar number. It's not like that. Aadhaar number is Aadhaar number. So we must do the search. See, this indexing is reducing the response time and the effort, but it's not actually doing well when the number of records grows high, right? It's a linear growth, right? So what is happening? SuperIndex DB is a new database which have been invented by us. So our name, I mean, our company name is SIndex DB in India. So recently we have completed the developing the SuperIndex DB, and that we are going to launch soon. Maybe when you are seeing this video, we could have launched that. At SuperIndex DB, we have found a solution for the problem which I was explaining. We found a new data structure. The new data structure name is called SuperIndex. Wow, our response times are always equal. Whatever the records are. That is what the secret of our data structure. If it is 1 trillion records, 1 million or 10 trillion or 10 million, whatever the records, our data structure will provide you the similar response time even when you had 100 records in the table in the database. That is a new innovation, which we have found from SuperIndex DB. How this is happening? How SuperIndex data structure works? It just directly go into the record without scanning others. See, just note down. We just directly go into the record without scanning other records in a table, other records in the indexing structure or anywhere. Uh, this is happens. That's what the data structure we have. Okay, if you see it in the picture-based way, like if you record, if the records are like this in the database, okay, it's okay. You see here, we do the same search, whatever the search we have done, in the plain database and the index-based database, similar way in SuperIndex, right? When we do the search, it just directly go to the record without scanning others, without comparing others. That's it. So it's great. It takes less than 0 0.5 seconds. Maybe we can say 0.5 seconds. But the same combination, what I was talking. See, I said, right, that address and the data type, that all depends, right? Number of records, it all depends for the response time. But when we compare the response time of the plain database and the indexing database, see the response time improvement. Here we say that whatever the total number of records are, it doesn't care. The response time is same, almost same. That's why O of n is almost 1. That's the concept in the industry. Big O notation, big O algorithm, big O algorithm. If you know that, yeah, even if you don't know, you just watch our videos. In one of the video, definitely I'll talk about big O notation and algorithms. Don't worry. Um, okay, let's come to the conclusion. Again, I want to reiterate what is SuperIndex DB? It's a solution to all the existing database issues. Like we have all the existing RDBMS features. SuperIndex DB serves all the old RDBMS features and existing NoSQL features. We are serving all the NoSQL features plus our new innovative SuperIndex data structure that solves all the response times, all the response time issues from the existing database, especially when the number of records are very high or huge, massive, SuperIndex option is available on top of the existing database features. Okay, if we elaborate in a table, right? So this is what one particular example we got it. The O of n is 1, almost 1 for us. So for example, 1 million records, the usual RDBMS databases without indexes, it takes 5 seconds. When it is 10 million, it's 7 seconds. 1 billion it's 12 seconds, 10 billion it's 16 seconds. As even SuperIndex DB also, without an index, without a SuperIndex, if you do the normal table search, yeah, the response times are similar, 5, 7, 12, 16. When you go for RDBMS databases with indexes, it improves and it goes to 2 seconds, 4 seconds, 6 seconds, 8 seconds. SuperIndex DB also maintains that with indexes. We also have index. Please note down that. See, when we have SuperIndex, we are not ignoring indexes. We are keeping that option. Why we are keeping that option means because we are giving the option to the end user. Sometimes end user feels, I want to keep indexes because the number of records are less or something like that. They can use it. So I mean, it's an option, uh, but we are not recommending to use, but it's an option. It's available to SuperIndex DB2, and that response times are 2, 4, 6, and 8 seconds. When we go to SuperIndex DB with the SuperIndex data structure, see the response times. We are not saying almost one. The O of n is not exactly one, but there is a little slow that 0.5 seconds to 0.6 seconds. It may vary, it may less also, but we are just saying that almost O of n is 1. Yep. So as I mentioned in the graph way, so without indexes, response times. Suppose this is an index, okay? It's a the below one is the number of record index, and the y-axis is the response time behavioral index. See, this is going like this, and when we have indexes, it goes in a different route, and when we don't have, so when we have super index, it goes into the different line. So that is what the picture talks about. As we already mentioned, you can also refer what is index from the Wikipedia site. Index is a data structure which improves the speed of the data retrieval operations on a database table at the cost of additional writes and storage. You can just understand it. I want to reiterate again. SuperIndex DB has three options. You can use a normal table mode search, or the traditional index search, or super index on columns. We can also use that. Okay. When we use a super index DB, this is a syntax for creating a super index and dropping the super index. If you want to create a super index, just specify the super index name and specify the table name. That just creates a super index. When we say drop super index with the super index name, just it drops the super index. That's it. So this is a way we do super index also. It's like a index, in the traditional way. This is a sample program from Java. JDBC. JDBC is a connection, right? We usually connect it from Java to the database using the driver. In SuperIndex DB also we have SuperIndex DB driver and SuperIndex DB client. Client is for just end users accessibility, end users connectivity to the database. And driver is the automatic program, right? The driver, we can use it in the application server or the web server, which will connect your Java or .NET to the SuperIndex DB. And this is the way it usually does. We just connect it to the SuperIndex DB. Before connecting it, we need to specify the driver. The driver is SuperIndex driver, and once the driver you initialize it, you just connect it to the SuperIndex cloud, SuperIndex cloud. I mean, that's what we are preferring, and I'll talk about this in the other videos, like what is our business catalog, I mean, business options and everything. And you can just, after connecting to the database, you can just create a table, and you can just insert a record, and you can select the record, you can update the record, you can delete the record, you can create the views, all the existing features we have. And plus we have a create super index and drop super index. Yes, maybe this video, right? If you have any questions, you may have, you will have, you must have it. That's what even we are expecting it. And when we have questions, just contact us. These are the contact medium, right? The contact number. It's an Indian number, plus 91 98456 89152. Our email address is contact us at the rate superindexdb.com, and our website is https://www.superindexdb.com. You can just when you go to the website, you have a lot of options to contact us. Like you can click the contact us page, you can click the support page. You can click anything over there, and we will definitely help you in that